Okay, Year 12, I'm just going to go over a couple of these questions so that you can, to make sure that you're able to do them before you come to class next lesson. Now, I did questions A and C in class, so I'm just going to finish up here, this integration by substitution. I'm going to do D, E, F and G. But what I want you to make sure you do is you have to go at these on your own. So anyway, let's have a go at D. So D, 1D. And what are we integrating? We're integrating x plus 2, x squared plus 4x plus 1 dx. And it tells us to use the substitution. We can see here, it says use this substitution of x squared, or u equal x squared plus 4x plus 1. So over here, I'm going to do this. I'm going to go let u equal x squared plus 4x plus 1. Therefore, du dx equals 2x plus 4. And I can write that as du dx equals, now I'm going to take that 2 out of that, so 2x plus 2, because I can see that I want it to look like this bit. And du equals 2x plus 2 dx. Okay, let's have a look. I go back to this one now. All right, so I've got x plus 2, and all of this is equal to u. So I can just go, by the way, that was to the power of 4. So times u to the power of 4 dx. Now I still can't integrate it because I've got a u variable in there and an x, and I'm integrating with respect to x. But I'm lucky because I can see here, this is almost, so I've got the integral of u to the 4 x plus 2 dx, and it almost looks the same as what I've got down here, but I've got to put a 2 in, so I'm going to u to the 4, I'm going to put a 2 in, 2 x plus 2 dx, which means I'm going to be able to substitute du in, but I just can't do that. But because it's a constant, if I put that a half out the front, that's like multiplying and dividing by a half and by 2 at the same time, which means it retains its integrity. So I get a half, and now I can change all this for du, which means I get u to the 4 du, which is really easy to integrate. You get a half u to the 5 over 5, oops, don't forget your constant, plus c, which equals u to the 5 on 10 plus c on 2. Substitute back in, what was u? X squared plus 4x plus 1. X squared plus 4x plus 1 to the 5 over 10. And this is just some constant which will change to k. Righto, that's pretty easy. Let's have a go at E. So E, I'm going to write it down here, and we're going to integrate 2x plus 3 on x squared plus 3x minus 1 all cubed. Now again, I'm going to have to do a substitution. If I look here, they tell me to let u equal that. Okay, so let u equal x squared plus 3x minus 1. Therefore, du dx equals 2x plus 3. So du equals 2x plus 3 times dx. Okay. And what have I got over here? Well, I've got the integral of 2x plus 3. Now I'm going to write this differently because that's just to the minus, times, I'm going to use my understanding of index notation to realise that that is to the negative 3 because it's underneath dx. And now I can just go, okay, it's 2x plus 3, and this is u to the minus 3, and this is dx. Now I'm not going to write that whole line that I did above again. I can quickly see that that and that is du. So I can quickly do my substitution now. I've got u to the minus 3 du. Now it's easy to integrate because I add 1 to the power, so it's u to the minus 2 divided by minus 2 plus some constant. And I just have to put my substitution back in, which is x squared plus 3x minus 1 to the negative 2. I put the negative out the front and the 2 on the bottom, plus my c. But I'd like to put it back the same way that I had it, which was with that numerator, because it's raised to a negative power down below. So I'm going to put a 1 on top. I'm going to have 2x squared plus 3x minus 1 plus some constant. And I'll just check. And did Margaret write it like that? Yes, she did. Oops, I forgot the squared. That was a bit lucky. Righto. Let's have a go at f. I'm going to do f over here. Let's have a look at what it is. 3x on the square root of 2x minus 1. 3x on the square root of 2x minus 1 dx. And they tell me to use the substitution 2x squared minus 1. And that's a squared. So I've got to let u equal 2x squared minus 1. Now, I want you to go and have a go at it and then come back and see how you go with this. All right, so what I'm going to do, I differentiate du dx, gives me 4x. du equals 4x dx. Now, equals the integral 3x times, I'm going to write this in index notation, 2x squared minus 1 to the half negative dx. Now I'm going to do my substitution, and I've got 3x u to the minus a half dx. Now my problem is, and I'm going to write it, u to the minus a half 3x dx. And you're thinking to yourself, well, how can I make that and that look the same? Some people do this. They write du equals a quarter 1 on 4x dx. And they just put that in. All right. I personally would take that 3 out and put a 4 in, and watch what happens when I do this method. So it's an alternate method. So I'm going to do this 2 ways. I'm going to do it first this way, and I'm going to go back and do it the way that I would do it. Anyway, so I'm doing this way because I saw some kids do it. I'm going to substitute that in for dx. So what have I got? I've got u to the minus a half, 3x times, and I'm going to put the substitution in, a quarter, 1 on 4x du, and the x's cancel, and I get 3 on 4 u to the minus a half du, and because that's a constant, I can take that 3 on 4 out the front. So if that makes that easier, because what I would do, so there you can see, now it's easily integral. I'm going to go over here and I'm going to take the 3 out the front, so that u to the minus a half x dx. But what I've got to do is I've got to make it look like a 4x. So I'm going to u to a negative a half, put the 4 in, just do that in a different colour, put 4 in and take or divide by 4 outside. So I end up getting the same thing, 3 on 4, u to the minus a half du. Right? So I end up with the same thing. So that gives me 3 on 4, add 1 to that, which gives me u to the half. Divide by that, well, that's multiplying by the reciprocal, so we'll get 2 u to the half plus some constant. Now if I multiply the 3 on 2, that gives me the 3 on 4, that gives me 3 on 2 u to the half plus 3c on 2. So I put my substitution back in, which is 2x squared minus 1. So I get 3 on 2 square root, because that's what u to the half is. Oh, well, I won't do that step straight away because I might confuse some people. 2x squared minus 1 plus 3c on 2, and that's to the power of a half, which gives me 3 on 2 root 2x squared minus 1, and I'm just going to change that to some big constant k. And I'm checking, and there we go, we're right. Okay. So I'm now going to do G, the last one. You go and have a go at it yourself if you want, but I'll just finish this one off. So G. And I've got to integrate x squared on x cubed plus 1 to the 4. X squared on x cubed plus 1 to the 4 dx. Double check. X squared on x cubed plus 1, and we're using x cubed plus 1 as my substitution. So here we go. Let u equal x cubed plus 1, and du equals du dx, 3x squared. Therefore du equals 3x squared dx. Now, oops, x squared x cubed plus 1 to the negative 4 dx. Put my substitution in. So put u in for that. I'm going to get x squared u to the minus 4 dx. I can't integrate that because I've got two different variables in there, but I can see very quickly here I just need a 3x squared. So I'm going to put a 3 in and take a 3 out. And because it's all multiplied, it doesn't matter. This whole thing is multiplied. And I will get a third integral u to the minus 4 du. Now that's really easy to integrate, which gives me a third. Add 1 to the power, that's u to the minus 3. Divide by that, negative 3, plus some constant. Multiplied by the third out the front, I get u to the minus 3. Put the negative out the front on 9, plus c on 9. Put my substitution back in, which was x cubed plus 1. So I get negative x cubed plus 1 over 9. Plus, I'm just going to call this a big constant k. And that's to the negative 3. Negative 1. And that pulls all that down. That negative pulls all that down. X cubed. Oh, don't forget your 9. Sorry. 9 x cubed plus 1 cubed plus some constant. And there we go. That's correct. So there are your substitutions. Remember, if you want to, you can write du or dx in terms of du and substitute in. I saw some people doing that after class. That's okay. I don't like to do that. I like to do the hokey pokey. Oh, it's gone now. Come back to me. I like to do the hokey pokey like I did here. Put the 3 in, take the 3 out because it's all multiplied. Anyway, good luck.